In this video, we are going to look at disconnects and how health index is being applied to this asset. Let us start with the degradation modes for disconnects. There are two assets that I want to talk about, and they are the disconnect switches and the porcelain cutouts. Now, the switch blades and working mechanisms are the most important parts of the disconnect switch. Now, excessive arcing during switch opening or closing can be caused by misaligned or improperly surfaced contacts, leading to increased blade deterioration. Corrosion can cause the links and pins in the operating mechanism to corrode, slowing down the blade movement. Other flaws that may occur with age include broken grounds or damaged insulators. Disconnect switch enclosures that are installed on the pad or vault are susceptible to corrosion from road salt. Other major faults that might emerge with age include non-functioning padlocks and damaged interface barriers. So to summarize, the key degradation mechanisms generally for a switch includes linkage mechanical degradation, corrosion of working rod or steel hardware, switch blades becoming misaligned, resulting in excessive arcing, interconnections that are unsecure, the actual operation of the switch can be a form of degradation as well if it operates too much, for instance, because it is a moving part, damage to the insulations, as well as if there are any absence of ground connections. The rate and intensity of these degradation processes are influenced by a number of interconnected elements, such as the equipment's operational duties and the environment in which it is installed in. Corrosion or rust is a critical deterioration process in most circumstances, and the rate of degradation is significantly influenced by the environment in which the equipment is used. Corrosion around the mechanical linkages by these switches is common, and it can cause the switch to stop working. The switch functioning mechanism may cease if the lubricant dries up, rendering the disconnect switch useless. Air pollution, albeit a less common mode of degradation, can also impair support of the insulators. And this is most common in heavily industrialized areas or locations where road de-icing salt is usually utilized. Switches are rarely used for switching, but they are actually regularly utilized instead to actually decrease loads considerably below their rated capacity if need be. And as a result, mechanical failure is frequently used to determine switch aging and eventual end of life. So for example, rusting of the enclosures and the ingress of moisture and dirt into the switch, causing corrosion of operating mechanism or the degradation of the insulated barriers. Now, the other asset I wanted to go briefly over are the porcelain cutouts. Though external factors might cause cutout failures, the production of the cutouts themselves is actually a significant component in cutout quality and degradation. Damage to the cutouts during shipment or installation can cause issues. The ceramic insulator is bonded with all metallic attachments, and hence that can cause some issues. A possible weak point could result from improper cementing, and during the summer, high temperatures can cause metal to expand and shatter the porcelain insulators, and the lower withstand voltages come from damaged insulators can lead to failure. What's more, to prevent moisture penetration into the cement, paints or epoxies are employed as a sealer. Moisture may enter the insulator if the seal begins to break, and the porcelain can break due to changing environmental conditions, such as freezing and thawing, resulting in insulator failure. Moisture penetration, which in most cases starts at the top insert and progresses into the center hollow, can cause damage to a porcelain cutout. Moisture penetration and freeze-thaw cycles are minimized with the use of appropriate silicone cement and stainless steel inserts. Porcelain is far more fragile than polymer in comparisons, and chips can form during transportation and installation, creating failure sites and causing the cutout to fail prematurely. Damaged insulators are the equipment's first signs of failures. High electric fields may develop from chips or cracks throughout the uneven area. Small leakage currents from the conductor to the pole, bracket, or crossarm would result from these electric fields. And when the cutout is activated and a face-to-face voltage is present across the insulator, leakage currents can form. Leakage currents ionize the air and heat the porcelain, causing possible arcing and dielectric breakdown. And because partial discharge creates heat and stress, which might result in a more irregularly shaped insulator, this is a self-perpetuating process, and the cutout will eventually fail or cause damage to the surrounding equipment. It is possible to see electrical tracking when a cutoff is destroyed, and continuous partial discharge results in electrical tracking. This would eventually may lead to pole fires and equipment damage. Porcelain cutouts have an extremely high failure rate because to all of the reasons I just mentioned, including environmental, mechanical, and electrical stress, as well as manufacture and installation problems. Now, the condition of in-service disconnect switches and cutouts is determined by a combination of service age, visual inspection, and infrared testing. Visual inspections are frequently the most effective method for detecting common problems that, if not addressed, can escalate to more serious problems. Visual inspections of disconnect switches and cutouts can reveal things such as radial cracks, flashover burns, copper splash, copper wash on support insulators, signs of corrosions, cracks, deformation, abrasion, or blockages on the blades, as well as revealing some operating mechanism conditions such as overheating or degradation signs in the control cabinet, or any signs of moisture, condensation, or insect infiltration in those operating mechanisms. Now, infrared temperature measurement, or IR test, can provide a non-contact method of identifying localized temperature abnormalities in these equipment, and increased electrical resistance can cause by component failure, fatigue, and mechanical misalignment, in which it will lead to these thermal changes that can be detected by the IR test. And the use of infrared emission of these testing equipment to assess the temperature is based on the fact that the IR emissions increase with temperature in a predictable manner. And as a result, infrared scanners see heat in the IR spectrum the same way they perceive light in the visible spectrum. And any component that is likely to produce hot spots during operations, such as loose, oxidized, or corroded connectors on an overhead line or cable, or in a switch or relay contact, should be scanned using a IR equipment, such as an IR camera. And the electrical parts that are defective may also operate at a lower temperature than usual. So be sure to check that out as well during your IR test. Now, before we move on further into our course, let us take a brief look at our sponsor for this course. Now, as an engineer, especially when I first started in my career, I really felt overwhelmed the list of documents that we need to do on top of our technical work. Yet, these documents are very important in our career as it is the more prominent thing that displays our credibility to management and to our clients if we so decide to become an engineer consultant, which is where the real actual money is. Now, I don't have these tools available to me when I first started my career, but now PM Milestone has created this package of all the professional templates that you need so that you can focus more on the technical aspect of your career. These templates are tried and tested by real professionals, so you should feel confident in using them in your career to present your best foot forward in front of your manager or clients. These templates are also updated periodically, and I think their last update is just 2021, so they're not going to be out of date or context to the present times, as these people are serious in getting the most professional product to meet your needs. They're also very confident of the quality of these templates too, as they offer you their product completely risk-free with 60-day money-back guarantee if you are not satisfied with it. So, if you are interested in this product and would also like to support me in creating these courses on YouTube in the future, please check out their product using the link in my video description titled Course Sponsor PM Milestone 2.0. So now let us go over the different categories that composed of the disconnect health index. So of course, the first category is age. So for a rating of 4, it means that the disconnect or cutout is between 0 to 10 years of age. A rating of 3 means that it is between 11 to 20 years of age. Rating of 2 means it is between 21 to 30 years of age. Rating of 1 means that it is between 31 to 40 years of age, and any of those disconnects or the cutout over 40 years of age, we will assign a rating of 0. So the second one is the condition of insulators. With a rating of 4, it means that the support insulators are of good condition, which means that they're not broken and are free of chips, cracks, flashover burns, copper splash or copper wash, and the cementing and fasteners are secure. So overall, good or perfect condition. With a rating of 0, they are good, but there are some minor chips or cracks detected. With a rating of 2, these minor chips and cracks are actually now major chips and cracks, and there may also be some evidence of flashover burns or copper splash or copper wash, but the cementing and fasteners are still secure. With a rating of 1, it means that the support insulators are actually be deemed as damaged or broken, and that the cementing or fastening are actually not secured. And lastly, for a rating of 0, it means that the support insulators are beyond repair. Moving on to the third category, which is the condition of the blades. So with a rating of 4, it means that the blades are in good condition, which means that they're clean, free from corrosion, cracks, distortion, abrasion, or obstruction. The fasteners are deemed tight, and we can see that there are no visible evidence of looseness, loss of adjustment, or excessive wear on the bearings. For a rating of 3, it means that you could see minor signs of wears of the blades and the fasteners. For a rating of 2, it means that there are significant signs of wear, but the deficiencies are not critical to the safe operation of the switch. And for the rating of 1, it means that the blades are degraded and require replacement during the next scheduled outage. And lastly, for the rating of 0, blades are damaged and degraded beyond repair, and you should actually need an immediate replacement for these. Then we need to rate the operating mechanism. So for a rating of 4, it means that the operating mechanism is in good condition, which means that all parts are moving with adequate speed and no evidence of rust or friction in any of the moving parts. For a rating of 3, it means that there are normal signs of wear. And for a rating of 2, it means that there is significant wear on the operating mechanism, but those does not affect safe operation. For a rating of 1, it means that there are unacceptable level of degradation of the operating mechanism and would require component replacement or repairs during the next scheduled outage. And lastly, for a rating of 0, it means that the switch operating mechanism is defective, damaged, or degraded and requires immediate replacement. Lastly, we will look at IR test, and for this category, we only have 3 ratings, which is 4, 2, and 0. So for the rating of 4, it means that there are no hotspots detected. For a rating of 2, it means that there are noticeable hotspots, but they do not affect safety in its operation. And for a rating of 0, it means that there are very serious hotspots found. So now let us go over the health index weights of these categories. So in this case, we will rate the service H and the IR test higher, well, 2 times higher than the rest of the conditions. Whereas, so that service H and the IR test, we're going to give a weight of a 2 for both. And then for the condition of insulators, condition of blades, and condition of operating mechanisms, we will all assign the weight of 1. Now, one of the things that you would see that fuse cutouts don't really have an operating mechanism, so therefore this is not going to be included in the health index for fuse cutouts. So now let us go over an example. A disconnect switch of 22 years, which is a rating of 2, with minor chips on the insulators, rating of 3, and the blades are clean, rating of 4, and that there are normal signs of wear on the operating mechanism, which we give a rating of 3, and that there are no hotspots detected in the IR test, so we give it a rating of 4. So given all this information, calculate the health index for this disconnect switch. So of course, first you need to calculate the calculated score, in which basically you take the rating that you assessed, multiply by the weights of the respective categories and sum it up together. So in this case, it'll be 22. And then you calculate the maximum achievable score, which is the maximum score, which is the value of 4 multiplied by the sum of all weights. And that equals to the number 28. So the health index is 22 divided by 28 times 100, which is equal to 79. And as mentioned in the fundamentals section, a value between 70 to 85 is considered good. And as such, there might be deterioration of some components, but only normal maintenance are needed. Now, if you like this video, please don't forget to click like and subscribe to our channel. Our channel, the EE Bootcamp, has a wealth of knowledge regarding to the energy industry, so be sure to check it out. Also, this video is part of a playlist of the whole course, and so I've put the link to the playlist for this free course in the video description. As you may be aware, I'm a professional online instructor that teaches various topics regarding to the energy industry and offers certificate of completion at the end of each course. As you probably have noticed, this course needs fundamental knowledge in basic asset management. Physical asset management is important, and the skills are highly sought after in many large companies within the energy industry, or any industry that manages large asset in infrastructures for that matter. If you lack knowledge in physical asset management, look no further than my Physical Asset Management Fundamentals course offered at Electrical Engineering Portal, as in that course, I will provide you with the fundamentals that you need to kickstart your career in the physical asset management world. Another type of knowledge that you need for this course is fundamental information about the power distribution system. If you don't have enough experience in the industry, I would suggest you to enroll in my Distribution Power Engineering Fundamentals course hosted on Udemy, as in that course, I will walk you through the different parts of the power distribution system as well as basic design concepts that you will need to kickstart your career in the industry. Now, I have put the links to both of these courses in the video description also. Lastly, I have also included the link to my website in the video description that contains the information to all the courses that I offer, as well as other helpful resources that you may find useful in your career or in your learning path. Thank you, and I wish you good luck in your career. Remember, knowledge is power.